This problem wants us to determine a value of a parameter a that would make this function continuous, this piecewise defined function continuous everywhere. Now, because of the nature of these expressions here, if I were graphing just y equals 3x plus 1, I recognize that's going to be a line and it would be continuous everywhere I draw it, as long as there was no other restrictions. And so it's continuous and on the entire interval when x is less than or equal to 2. The second part of this function is also going to be a line, because once I know what a is, hopefully you recognize that would make the slope of this line equal to the number a, and this is going to be a line too, so it's going to be a continuous graph also. So the only chance that this whole function is not continuous is going to be as we have the x value 2. And so we want to remember the definition of continuity again, and it'll help us determine what value of a will make these two branches of the graph come together at the same point. The parts of the definition are, do we know the value of the function? In this case, we're working at x equals 2. So do we know f of 2? And I look there, and I do have a part of this rule that says what to do when x equals 2. It's right here, where it's contained within the expression x is less than or equal to 2. Within that is the equals 2. So if I want to find out f of 2, I simply plug it into 3x plus 1. And I'm going to do that now and do 3 times 2 plus 1, and I'm going to get 7. So the first part of being continuous is I have a value of the function, and I know that f of 2 is 7. Now the second part is I need to have a limit. And in this case, because we have different expressions used to the left and to the right of 2, we need to examine the limit from the two sides separately. So we'll examine the limit approaching 2 from the left, and we're going to examine the limit approaching 2 from the right. So in the limit from the left, I simply would use the expression that is defining the function to the left of 2, which is 3x plus 1. And this is a limit I can get an answer for just by plugging in my 2. And I'm going to once again get 7. But then coming from the right, I have to use the rule that defines the function to the right of 2, which is ax plus 5. And so I'm going to write that in my expression there. And to evaluate that limit, just like I would any of the other times, I will plug in the 2 where x is, see if I can see what I get. And this time I won't get a number, but I'm going to get a times 2, or I'm going to write it as 2a plus 5. Now, the definition of continuity says the value of the function and then the limit from the left and right had all better be the same. Now, 2 of them already are the same, so what I need to now just make sure of is, in order for this to be continuous, the limit from the right, which is 2a plus 5, has to equal the limit from the left. So the thing I have to do is solve this little equation that says the limit from the left side, 7, must equal the limit from the right, 2a plus 5. And I can now just solve that for a. And it's a pretty quick one. I'll just subtract 5 and get 2 equals 2a. And then I can quickly divide by 2 and get a equals 1. So we still were using the definition of continuity, just that we used it as a way to find out the value of a. The function value at 2 was 7. The limit coming toward 2 from the left was equal to 7. The limit approaching 2 from the right then needs to be made equal to 7. And since that limit would turn into 2a plus 5, that's the equation we had to solve. I have one more for us to look at that is similar. Now I encourage you to just look at this one maybe on your own first, maybe pause the video and try this one yourself as a way to see if you understood what happened in the last one. And then I'm going to go ahead and solve it. So here I would go, and once again, the continuity checklist would go like this. In this case, we're looking at x is 3. So do I know f of 3? And I do, because within here is x equals 3, and I would use the rule 2x plus 3 to get the value, and that is 9. And now we're going to look at the limit approaching 3 from both the left and the right. So we'll start with from the left. And when I'm coming from the left, the function is defined to be 2x plus 3, which again would make the limit 9. But now coming from the right, I must use the rule defined for values of x bigger than 3, which is ax squared. And this limit involves x. X is approaching 3 coming from the right. But I can get this limit just by plugging in 3 for the x squared for x and getting a times 3 squared, which I would call 9a. So in order for this to be continuous, the value of the function, which is 9, the limits from the left, which is also 9, all of that needs to equal the limit from the right. So the equation to be solved is 9 equals 9a. And this is a quick one just to get by dividing again by 9. A is going to equal 1.